Hey guys, this is Mrs. Harbin, and this is section 3.2. Today we're going to look at ratios and proportions as part of solving equations. Our biblical integration for our unit is this: Jesus set the highest standard for us to live up to by sacrificing all in service to his Father. We should be willing to do no less in our commitment to working for him. And this is just a reminder that everything that we do, we are working for the Lord and not for men. You are learning how to do these skills not just so you can pass the test and get good grades for yourself on your report card, but so that you can use these skills in whatever work or career it is that you choose to do to help other people and make this place better. Our lesson objective for today is that you, the student, will use proportions to solve problems and determine unit rates and convert rates. Let's talk about some definitions really quickly. A ratio is a comparison of two numbers by division and is often expressed as a fraction. If you remember, fractions are called rational numbers. Let's write out that word rational, and you should see that we have a similar root here between ratio and rational. And so ratio is a comparison of two numbers by division and is often expressed as a fraction. We use ratios a lot, and we're going to see some of those examples today. But really quickly, let's go over two other definitions. A rate is a special type of ratio comparing numbers with different units. You've been dealing with rates and ratios for many years now, even if you didn't quite know the terminology. Again, we'll go over some examples here in just a minute. A unit rate is a rate in which the denominator is 1. All right, let's talk about some rates that you guys might be familiar with. You might know, for example, that 12 inches is equal to 1 foot. That's a rate that you would know. It's a 12 inches per 1 foot. We can write it that way, so it has that rational number there. We're comparing numbers with different units. Up here we have inches, and down here we have feet. Or maybe you notice that when you're driving, the speed limit is 45 miles per hour. 1 hour. Okay, both of these rates are also unit rates because that denominator is 1. What are some other rates that you know? Maybe you know that there are 60 seconds in a minute, or 60 minutes in an hour, or 24 hours in a day, 7 days in a week, 12 months in a year, 52 weeks in a year. Those are all rates that you should be familiar with. We're comparing numbers that have different units, minutes to seconds, or hours to days. When writing ratios, we want to make sure that we reduce them to the lowest terms, just like a fraction. Ratios can be written in several different ways. You might see ratios written like this: 3/4. Maybe that means 3 out of 4. I went to the store, I bought 4 apples, and 3 out of 4 were red, and 1 out of 4 was yellow. Okay, so it can be written this way. We can write ratios this way. Again, this is read as 3 out of 4. So again, I went to the store, I bought 4 apples, 3 out of 4 were red, or I can say it as 3/4. Maybe you are making some lemonade, and lemonade has a ratio of 3 cups of lemon juice to every 4 cups of sugar. That would be a little bit on the sweet side, but we can read that as 3/4. So ratios show us the relationship between two different amounts or two different things. When writing ratios, you'll often want to write rates with their units. Units are just the words here. So we don't just want to write 4 to 3. We want to write 4 questions per 3 minutes. 4 questions out of 3 minutes. Maybe that's the rate of how quickly you need to take your math test. Answer 4 questions every 3 minutes. So we often want to write the units to help us keep track of which numbers go with which unit. Let's take a look at an example. A school of 312 children has 168 girls and 20 teachers. How would we write the ratio of girls to students? We can write it like this: 168 girls to 312 students. Or if you want to write it one of the other ways, we could write it 168 to or out of 312 students. When we reduce that it reduces to 7 over 13, which means for every 13 students, we would have 7 girls. How would we write boys to students? Well, if 312 children are there and 168 are girls, we know the remainder must be boys. So we would write that as 144 boys out of 312 students, or when reduced, 6 out of 13. So every 13 students, we would have 7 girls and 6 boys. How would we write girls to boys as a ratio? We would write 168 girls to 144 boys. Again, this is just a ratio or a fraction comparing two different units. In this case, our units of measure are girls and boys. Once reduced, we have 7 out of 6, or we have 7 girls for every 6 boys. How would we express this as a ratio? A school of 312 children has 168 girls and 28 teachers. What's our unit rate, students per teacher? How many students do we have for every 1 teacher? Remember, unit means 1, and we want to know that what our unit rate is. We're looking at our second number here, or this is the denominator, when it's 1. So how many students for every 1 teacher? Well, 312 students for every 20 teachers. 312 over 20. We can't really reduce that to a nice neat fraction, so we can use decimals instead if needed. And we find out that there are 15.6 students per 1 teacher. We did that by dividing 312 by 20. 312 by 20 converted that to a decimal and helps us know our unit rate, or how many students per 1 teacher. Let's quickly talk about the terminology for dimensional analysis. It sounds really fancy, but all it is, it's allowing you to convert a rate to an equivalent rate. We talked about some equivalent rates at the beginning. For example, 60 seconds is equal to 1 minute. Equivalent just means equal. So it allows you to change 1 unit to another unit. Maybe I need to change how many miles per hour I am driving to how many feet per hour I'm driving for some reason. Or maybe I need to change my inches into centimeters or something like that. So it allows us to convert a rate to an equivalent rate. A unit multiplier is a rate with different expressions representing the same quantity in the numerator and denominator. It's very similar to a unit rate. Okay? So a good unit multiplier would be 60 seconds equal to 1 minute. We have the same quantity, just expressed 2 different ways. 60 seconds is the same as 1 minute. Remember, when you have 2 numbers that are identical, one over the other, it's just equal to 1. So 60 seconds over 1 minute is equal to 1 minute. That is a unit multiplier. But what that unit multiplier allows us to do is to convert rates to equivalent rates. Multiplying a rate by a unit multiplier will not change the ratio, since that unit multiplier is just equivalent to 1. It's just allowing us to change our terms. Here's an example. If I wanted to change, I have 1 mile equals 5,280 feet. That's an example of a unit multiplier. And 2.4 centimeters is equivalent to 1 inch. Again, that's a unit multiplier. These are the same values, so this is equal to 1. These are worth the same thing, so this is equal to 1. The unit multipliers allow us to do a dimensional analysis and change from one unit of measure to another. So let's change 17,000 miles per hour, wow, that's fast, to feet per second. Let's say I was measuring in miles per hour and I need to measure it in feet per second. I'm not going to go back and do 17,000 miles an hour again, and watch my odometer. I could just do some math to convert that. So I know that, I don't know what goes 17,000 miles an hour. Maybe my rocket. Okay, my rocket's going 17,000 miles per hour. I've got to change my hour to seconds and my miles to feet. Let's start first with our unit multiplier that changes miles to feet. I know that there are 5,280 feet per mile. When I'm using a unit multiplier to change, I need my units of measure, 1 to be on the top and 1 to be on the bottom. I do not want it to be 1 mile on the top and 5,280 feet on the bottom. If I'm converting, I need it to be on the top in one place and the bottom in the other place. So that will change my miles into feet. But I also need to change my hours into seconds. I don't know how many seconds are in an hour, but I do know how many minutes are in an hour, and then I know how many seconds are in a minute, so I'm going to use 2 unit multipliers. I'm going to use 1 hour is equal to 60 minutes. Again, I have hours on the bottom here, so it needs to go on the top here when I write my unit multiplier. And I know that 60 minutes is equal to, well, 1 minute is equal to 60 seconds. Got my minutes on the bottom here, and my minutes on the top here, and I'm converting minutes to seconds then. All right, once I have my original number and the 3 unit multipliers that I need, I'm going to multiply just like I would multiply any fraction. I'm going to take 17,000 times 5,280. Notice the only one that didn't get crossed off at the top here was feet. And at the bottom, I'm going to do 1 times 1 times 60 times 60. Again, notice that the only unit of measure that did not get crossed off was seconds. So that will allow me to change feet per seconds. 1 times 1 times 60 times 60, or 60 squared. When I plug that into my calculator, I'm going to get 24,933 feet per second, approximately. This means approximately because it is going to give me a decimal answer. We can round that up to approximately 25,000 feet per second, depending on what place value they tell us to round our answer to. A proportion is a statement of equality between 2 ratios. We use proportions all the time. When you think about fractions, you know that 1/2 is equal to 3/6. This is a statement of equality between 2 ratios. 1/2 is the same as 3/6. So you should be familiar with proportions. Maybe you've not used them to solve problems, however, and this is where we're going to go. So A over B is the same as C over D. Again, looking at our numbers here, if 1 is A, 2 is B, 3 is C, that's a 6 here, and 6 is D. A over B is equal to C over D. We have some special terms here. Our top left term and our bottom right term are called extremes, and my bottom left and top right terms are called means. And when we're dealing with proportions, we know that there's a special relationship between our extremes and our means. We know that the product of the extremes is equal to the product of the means. Product just means multiplication. So A times D is equal to B times C. Let's see if that's true using some numbers up here. Okay, 1 times 6 should be equal to our means, 2 times 3. And if we multiply that, we see 1 times 6 is 6, 2 times 3 is 6, 6 equals 6. That is true. So we can use this rule, the product of extremes and product of means, to solve for some missing numbers. Let's take a look at what this would look like. Let's solve the proportion 7 over 8 equals x times 4. Well, using our extremes and means, we know that 8 times x is the same as 7 times 4. We'll then use what we learned in the previous 2 chapters to solve for x, and we find that x equals 3.5, 28 over 8, which can be reduced. Let's look at a real-world example where a car travels 250 miles on 9 gallons of gas. So we're going to set up our proportion with miles and gas as our 2 units of measure, or gallons of gas. How many gallons are needed to travel 360 miles? So we're going to use G as our variable here for how many gallons of gas we need. And we're going to keep our miles per gallons the same in both of our ratios. So our first number was that we went 250 miles on 9 gallons of gas. And we want to know, if we go 360 miles, how many gallons of gas will we need? We could use X, we could use Y, but in this case we're going to use G. We'll then use our product of extremes and our product of means to solve for G. And when we do so, we get 250. G equals 9 times 360, or G equals 12.96. That prompt, 13 gallons. Nice job.